The cheap little ceramic square you can buy online for around $4 right now is the exact same core technology that NASA bolts onto deep space probes to keep them powered for over 40 straight years in the freezing dark of outer space. And almost nobody in the prepping world realizes you can pull the same exact trick on your own wood stove this winter at home. Most people, staring at a completely dead phone screen during a long, extended blackout, never imagined for 1 second that the very heat from the wood fire keeping them warm could quietly be charging that phone the entire time. With no solar panel needed, no fuel cost, no batteries to wear out, and no moving parts to ever break down. Stay all the way to the end of this one, because the single most important wiring detail in this entire build is the one that almost everyone gets completely wrong on their very first try. And one small extra component costing about $5 turns this whole hack from a fragile curiosity into a real working off-grid power station. Here is the genuine science quietly powering this entire hack. And it is something a German physicist named Thomas Seebeck actually discovered way back in 1821. Seebeck noticed that when two different metals are joined together and one end gets hot while the other end stays cold, a small electric current actually flows spontaneously through the connection without any battery or power source attached anywhere in the system. That single observed phenomenon is now called the Seebeck effect. It is the exact same fundamental physics principle that powers everything from this cheap homemade phone charger all the way up to the plutonium-fueled generators on the Mars rovers operating right now. The little ceramic square that costs $4 is technically called a Peltier module, with the most common model number being the TEC112706, available on Amazon, eBay, AliExpress, and most major hobby electronic suppliers. It is a tiny 40mm by 40mm sandwich containing roughly 127 pairs of specially doped bismuth telluride semiconductor cubes, wired together in a long electrical series between two thin ceramic plates that conduct heat but not electricity. When one side of this module gets significantly hotter than the other side, those semiconductor cubes generate a real voltage difference across the wires, and you can use that voltage to power small electronic devices like a smartphone or a flashlight. The hotter the temperature difference becomes between the two sides of the module, the more voltage and current the device actually produces, in a roughly linear relationship up to its maximum safe operating temperature of 138 degrees Celsius. At a temperature difference of around 100 degrees Celsius between the two sides, a single TEC112706 module produces somewhere between 3 and 5 volts of direct current at a few hundred milliamps of measurable current output. That is honestly more than enough raw electrical power to charge a modern smartphone over the course of several hours of continuous wood stove operation during a normal winter evening at home. The whole reason this even works in real life is that a typical wood stove operating at full burn temperature reaches surface temperatures of around 200 to 300 degrees Celsius along the side walls and the top cooking surface. So if you press the hot side of the Peltier module against that scorching stove surface and keep the cold side reasonably cool through any decent heat sink, you naturally create the exact temperature gradient needed to generate real usable electricity. Now here is where almost every single first-time builder makes their critical first mistake, because they assume any cheap Peltier module from Amazon will simply survive being placed directly on a glowing red hot wood stove without any problems. The honest, hard truth is that the standard TEC112706 module is actually manufactured for cooling applications, not for high-temperature generator use, and its internal solder joints melt at around 138 degrees Celsius. If you bolt this cheap cooling module directly to a stove surface that reaches 300 degrees Celsius on a serious burn, the solder inside literally melts within minutes, and the entire ceramic module is permanently destroyed without any chance of repair. So the real first trick to making this hack actually work long-term is to install a real thermal buffer between the stove surface and the Peltier module to keep that hot side temperature safely below the critical solder melting point. The cheapest practical buffer is honestly just a thick piece of solid aluminum or solid copper plate, ideally somewhere around 1/4 inch thick and at least 4 inches square in total surface area. That solid metal plate sits flat directly against the hot stove surface and quickly absorbs significant heat, while gradually transferring a more controlled and moderated temperature up into the Peltier module mounted on top of it. A small layer of high-temperature thermal paste, the same exact kind used for computer CPU cooling and available for around $5 per tube, goes between the buffer plate and the module to maximize the actual heat transfer efficiency. For users with serious budgets, the smarter long-term upgrade is to skip the cheap TEC112706 entirely, and instead buy a real thermoelectric generator module like the TEG112611 model. Real TEG modules are specifically designed for high-temperature generator use, with solder rated for continuous operation up to around 300 degrees Celsius, or even higher in some industrial variants from companies like Custom Thermoelectric and Thermodynamic. These genuine TEG modules cost noticeably more, somewhere around $20 to $50 each, but they will reliably last years of constant wood stove use without ever melting or degrading internally. For the absolute lowest budget builds, the cheap TEC 112706 honestly still works fine if you use the buffer plate approach and carefully monitor your stove temperatures during use. Now, here's the second critical part that nobody really explains well anywhere online, which is the equally important cold side of the entire setup that gets ignored constantly in tutorial videos. The Peltier module honestly only produces electricity based on the temperature difference between the two sides, not on the absolute hot side temperature alone, so a hot side at 300 degrees with a cold side at 290 degrees produces almost zero usable power output. You absolutely have to keep that cold side genuinely cold during operation, and the simplest practical method is to mount a substantial finned aluminum heatsink directly on top of the module using more high-temperature thermal paste between them. The bigger and more heavily finned the heatsink, the better the natural air convection cools the module, and the more usable electrical power the entire system actually produces during a stove burn cycle. A standard computer CPU cooler with a small attached fan honestly works beautifully for this exact application, and you can pull one for free out of any old broken desktop computer sitting in a closet or local thrift store. If you actually run that small attached fan to actively cool the heatsink, the temperature difference across the module increases dramatically, and the power output of your entire generator can easily double or even triple from passive cooling alone. But here is the genuinely clever recursive trick that makes this whole setup self-sustaining over time, because the Peltier module itself produces enough electricity to run that small cooling fan continuously without any external battery needed. So once you initially light the stove and the module starts generating its first volt or two of power, you simply wire that output power back to the fan starts spinning, the cold side gets noticeably colder, and the power output increases automatically in a beneficial positive feedback loop. This is honestly the exact same elegant design principle used in the popular commercial EcoFan wood stove fans that sell at hardware stores for somewhere between $100 and $200 each. Those commercial fans contain literally nothing more sophisticated than a Peltier module sandwiched between a hot side base plate and a cool aluminum heatsink, driving a tiny direct current electric motor with the generated electricity. A homemade version of that same exact device costs you under $20 total in parts, and with one simple wiring modification, it can also charge your phone at the same time as it cools itself. Now here is the third absolutely critical component that turns this hack from a fragile science experiment into an actually reliable working off-grid charger over many hours. The raw voltage coming directly out of the Peltier module is genuinely unstable and varies dramatically with the constantly changing fire temperature inside the stove during a normal burn. When the fire burns brightly and hot, the module might output 4 or 5 full volts of usable power into your wiring system. When the fire dies down to glowing coals or the stove cools off significantly, the module might drop down to only 1 or 2 volts of weak power. A modern smartphone absolutely requires a steady regulated 5 volts at a minimum to charge properly through any standard USB connection without errors. So you simply cannot just connect the Peltier wires directly to a phone charging cable and expect any reliable result, because the unstable voltage will confuse the phone and may not charge it at all in many cases. The solution that elegantly fixes this entire problem is a tiny, inexpensive electronic circuit called a USB boost converter, available on Amazon for around $5 to $10 per piece. This small circuit board takes whatever variable voltage you feed into it, anywhere from around 0.9 volts all the way up to about 5 volts of raw input, and outputs a perfectly stable regulated 5 volts at up to 1 full amp of clean current. The most popular and reliable model for this exact application is genuinely called the MT3608 Step-Up Boost Converter, which honestly costs only about $2 to $3 on AliExpress or eBay. For a slightly more capable upgrade, the XL6009 boost module handles higher input currents and produces a more stable regulated output under heavier loads. You wire the 2 raw output wires from the Peltier module directly into the input terminals of the boost converter. And out of the converter comes a perfectly normal USB port, ready to charge anything that you would normally plug into a wall outlet. That single $5 component is honestly what completes the entire system the title quietly hinted at, because without it, the hack genuinely barely works at all under normal conditions. With it, your wood stove genuinely becomes a fully reliable USB charging station that runs continuously for the entire winter without any extra fuel cost beyond what you already burn for heating the house. Now let us talk about how much actual usable power you can realistically expect from this whole homemade setup during normal real-world use. A single TEC112706 module running at a healthy 100 degrees Celsius temperature difference puts out somewhere around 2 to 4 watts of continuous electrical power. That is enough total power to slowly charge a smartphone over about 3 to 6 full hours of continuous wood stove burn time. It is also genuinely enough power to run a small LED lantern, charge a USB-powered emergency radio, or top off rechargeable AA batteries inside a small USB battery charger. If you wire multiple Peltier modules together in series and parallel arrangements, you can scale this entire power output up significantly to charge much larger devices. 4 modules wired correctly together can produce somewhere around 10 to 15 watts of total continuous power, which is honestly enough to charge a small tablet or run several small electronics simultaneously. 8 modules in a serious, larger setup can push past 25 watts of total power, which starts approaching the territory of small solar panel output performance. The honest, beautiful part is that unlike solar power, this system genuinely works all night, in cloudy weather, in heavy rain, in deep snow, and during the absolute coldest winter weeks, when you need power the most. It also works perfectly indoors, with literally 0 noise output and 0 exhaust fumes, since the stove was already burning safely for your home heating needs anyway. Now let us walk through the actual practical step-by-step build process for a basic version of this system that anyone can complete in one afternoon. You start by buying one TEC112706 module for around $4. Total online. You also buy one MT3608 USB boost converter for around $5 at the same exact time. You need a small piece of solid aluminum or copper plate, ideally 1/4 inch thick by 4 inches square in total dimensions. You need a small computer CPU heatsink with an integrated fan, easily salvageable for completely free from any old desktop computer sitting unused in a basement. You need a small tube of high-temperature thermal paste, costing around $5 at any local electronics store or auto parts shop. You need a few feet of standard 22-gauge electrical wire and some basic small alligator clips for testing connections quickly. That genuinely is the entire complete parts list, and the total cost comes to somewhere around $15 to $20 total, even if you have to buy everything completely new at retail prices. Now for the actual physical assembly process from start to finish. You drill 2 small holes through the aluminum buffer plate so you can later bolt it securely to your wood stove using high-temperature stove bolts. You apply a thin, even layer of thermal paste to the top side of that buffer plate, where it will contact the Peltier module. You place the Peltier module flat on top of the buffer plate with the side marked TEC facing up toward the cool air, and the unmarked smooth side facing down toward the hot plate. You apply another thin layer of thermal paste on top of the Peltier module, covering its full surface area evenly. You place the CPU heatsink directly on top of the module, with the fins pointing straight up toward open air for maximum natural convection cooling. You can use small spring clips, JB Weld high-temperature adhesive, or even thin wire ties to physically hold the heatsink firmly against the module surface. You connect the 2 output wires from the Peltier module to the input terminals of the boost converter, making careful note of the positive red and negative black polarity markings. You connect the boost converter's USB output port to whatever phone, light, or other small device you want to charge with this system. You bolt or clamp the entire assembled buffer plate to the side of your wood stove, ideally on a vertical side wall where it gets consistent, steady heat exposure throughout the burn cycle. Now here is one final practical pro tip that almost no tutorial video online actually mentions clearly anywhere. You should genuinely add a small inline 1 amp glass fuse on the positive output wire from the Peltier module before it reaches the boost converter input. That single tiny fuse genuinely protects your boost converter from any electrical surges that can happen when the stove temperature suddenly spikes during fresh wood loading. Without that fuse, a single sudden voltage spike can easily fry the entire boost converter and force you to rebuild the system from scratch. A pack of 10 replacement glass fuses costs literally $2 at any auto parts store and saves you hours of frustrating troubleshooting later on. Now let us talk about the variations and serious upgrades that experienced builders actually use to take this hack from a basic build to a genuine permanent solution. The first major upgrade is to switch from the basic TEC cooling module to a real TEG generator module, which can safely handle much higher operating temperatures without melting internally. A genuine TEG 112.6116.0 module from a company like Custom Thermoelectric is rated for hot side temperatures up to 250 degrees Celsius continuously. It produces around 5 to 7 volts at a useful 300 milliamps under those exact conditions, which is genuinely enough power to skip the boost converter entirely in many cases. The The second major upgrade is to add a small lithium-ion battery pack with proper charging circuitry between the boost converter and the actual devices being charged. That intermediate battery stores excess power generated during peak stove burn periods and releases it slowly during the quieter, cooler periods when the fire is just smoldering. A simple 18650 single-cell lithium battery with a small TP4056 charging board costs around $8 total in parts. That combination effectively turns your stove into a permanent charging power bank, which never runs out of capacity as long as you keep feeding wood into the fire. The third practical upgrade is to use water cooling on the cold side of the module instead of air cooling fins. A small block of solid copper with internal water channels can be paired with a tiny aquarium pump and a small radiator to circulate cold water continuously. This water-cooled setup can maintain a temperature difference of 150 degrees Celsius, or even more across the module surface, dramatically boosting power output. Some advanced builders even route the warm water output of this cooling loop into a small heat exchanger to preheat domestic hot water as a useful side benefit. The fourth upgrade is to stack multiple Peltier modules in a sandwich configuration with shared heat sinks for compact higher power density. A 4-module stack on a single shared buffer plate can produce around 10 to 15 watts continuously in a footprint barely larger than a single module. The fifth practical upgrade is to add a small solar charge controller as a power management hub for the entire setup. That same charge controller circuit, designed originally for solar panels, works absolutely perfectly with the stable regulated DC output coming from a thermoelectric generator system. It cleanly handles battery charging, automatic load switching, and reliable overcharge protection all in a single inexpensive $10 component from any local hardware store. You can also adapt this exact same general hack to work with sources other than just a traditional wood-burning stove. A propane camping stove during cooking, the side of a kerosene heater during operation, or even the exhaust pipe of a small portable generator, all produce serious, useful heat that the same module can harvest into clean electricity. Some genuinely creative builders have even mounted Peltier modules directly on the exhaust pipes of their parked vehicles to harvest useful waste heat during long road trips into power. The exact same technology is sold commercially as the popular BioLite Camp Stove 2 model, which costs around $150 at outdoor retailers nationwide. That whole commercial unit is genuinely nothing more than a small wood-burning camp stove with one Peltier module bolted to the side wall feeding a USB charging port on the body. Your homemade version, using this hack, does essentially the exact same thing for about 10% of the retail price of the commercial unit at the store. The PowerPot V is honestly another famous commercial version, selling for around $150 at outdoor stores. It is genuinely just a cooking pot with a Peltier module built directly into its base, charging a small USB port using the heat from any campfire or stove. Now here is the most important safety information that you absolutely must understand clearly before building or using any version of this hack at home. Wood stove surfaces routinely reach temperatures well above 250 degrees Celsius during normal operation, which is dramatically hot enough to cause severe third-degree burns instantly on bare skin contact. You must always firmly bolt or clamp the Peltier assembly securely to the stove. Never just rest it loosely on top, where it could easily slide or fall off during use. You must always use high-temperature thermal paste, rated explicitly for at least 200 degrees Celsius continuous operation. You must always keep all the wiring well away from any actual open flame contact and away from the absolute hottest stovepipe surfaces. You must always use silicone-insulated wire, rated for at least 150 degrees Celsius temperature exposure for safety. A small, inexpensive infrared thermometer, costing around $20 at any local hardware store, lets you reliably check the actual stove surface temperatures before installing anything permanently. That cheap thermometer saves you from melting expensive Peltier modules and helps prevent any real serious fire hazards in your living space. So that is genuinely the entire complete hack, from the basic 200-year-old underlying science to the exact wiring details that make it actually work reliably in real life. Buy the $4 Peltier module, buy the $5 boost converter. Salvage a free CPU cooler from an old computer. And you have just built a working off-grid phone charger that runs for free every single winter, every single day, for the rest of your life, with no fuel cost beyond the wood you already burn for heat.